I know that his father spoke to me. Okay, so now we will start the class. So yesterday we learned about nucleophilic substitution reaction. Today we will be learning about electrophilic substitution reaction. Okay. So some introduction I gave you. Electrophilic substitution reactions you learned in 11th standard, isn't it? So the reactions like nitration, chlorination, sulfonation, and alkylation, acylation, these are the electrophilic substitution reactions. And last year you learned that, see, chlorination. So electrophilic substitution reaction means electrophile. Electrophile is, children are disturbing us a lot. Okay, so electrophiles are electrons loving. So they will be negatively charged. Suppose the reaction is nitration. So the electrophile is NO2 plus, isn't it? Suppose it is chlorination. The electrophile is Cl plus. Alkylation. The electrophile is CH3 plus. So the electrophiles will be positively charged. It will come and attack the carbon where there is negative charge. So that is why we are saying they are electrophile, electron loving, isn't it? So here, where, so in this case, one chlorine is at the carbon 1, then 2, 3, 4, 5, 6. So out of these 5 carbon, where the electrophile will go, that is decided by the group already present in the benzene ring. Last year you learned. So there are 2 types of groups. Some groups are ortho-para directing, some groups are meta-directing. These are the things you learned in 11th, isn't it? So chlorine is which, ortho-para directing or meta-directing? It is ortho-para directing. So the incoming group will come to ortho and para position. Okay, so we will start with the electrophilic substitution reaction. So first we can say chlorination, halogenation. Chlorination, what is the reagent? Chlorine in presence of an halogen carrier. It can be iron and iron chloride. So in your book they have given us anhydrous ferric chloride. Halogen carrier is required. So
also aluminium.
So in this case you will get orthochloro. Orthochloro. Oh no, it is 1,2-dichlorobenzene and 1,4 ortho and para position. It will go, isn't it? And this is chlorination. Next one is, have you understood? Write down. So first electrophilic substitution reaction is chlorination. Then the next, this is the first one.
Ma'am.
Next we will write a nitration.
Ma'am. Ma'am, am I audible? Ma'am, I had a doubt. In book they have mentioned for 1,2-dichlorobenzene as minor.
What?
And for 1,4 in book for 1,2-dichlorobenzene they have mentioned as minor. Dichlorobenzene.
No, the name you are saying.
Yeah. Yes, ma'am. They have mentioned it as minor.
It is 1 and 2, no? 1,2-dichlorobenzene.
Yes, ma'am. They have mentioned it as minor.
Mentioned it as what? 1,2-dichlorobenzene only. Major and minor you are saying?
Yes, ma'am. There is a small doubt.
Major and minor product?
Yes, ma'am. Yes, ma'am.
That is para will be major. Because it is away from this, no? So major will be para, major product. Minor. So this will be formed in more percentage. Understood?
Why is it like that?
Clear now?
Why is it major?
Why? Because see here, it is away from that, no? This chlorine. So this will be produced more. Para, always para will be major.
So the
This
repulsions
is
will be less and
closer, no?
Ma'am, that is the minor product. 1,
Minor is
2.
or this is minor. And
Okay.
the name is 1,2-dichlorobenzene. Okay.
Ma'am, can you explain once again why it is major and minor? I didn't get that thing properly.
Because see here the chlorine is near to this chlorine. Na? This one is away from it. You can say some sort of steric. So this will
Okay,
be
got it.
formed more.
I know. Got it.
So para is the major product.
Okay.
Okay. We'll go to the next reaction. Next reaction is nitration. So nitration, this is chlorobenzene. What is the reagent for nitration? Concentrated, a mixture of always nitration. Last year you learned the mixture of nitric acid and concentrated nitric acid and sulfuric acid. That is called nitrating mixture. So whenever nitration takes place, we have to put nitric acid and sulfuric acid. So what will happen? NO2 will go to ortho and para position. So you will get ortho-nitrochlorobenzene, correct? Ortho-nitrochlorobenzene and para-nitrochlorobenzene. This is para-nitrochlorobenzene. So ortho-nitrochlorobenzene and para-nitrochlorobenzene, that is nitration. Understood? So chlorine is ortho-para directing. So whatever the electrophile will go to ortho and para position. That only you have to remember that. Chlorine is or halogen. Any halogen is ortho-para directing. Clear? What probably, Anand? What is more stable? Okay, para. So next one is sulfonation. Sulfonation, the reagent is sulfuric acid. So what will happen? Which group will go sulfonation? SO3H. Last year you learned, na? SO3H. So on sulfonation, SO3H will go to para and ortho position. So whenever sulfonation, you will name it as derivative of benzene sulfonic acid. So it is ortho-chlorobenzene sulfonic acid. This is para-chlorobenzene sulfonic acid. Is it okay? So when sulfonic acid comes alone, you will name it as benzene sulfonic acid and halogen will be, you give position as ortho or para. Okay? Or you can say 2-chloro-benzene sulfonic acid. That is also correct. Ortho-chloro-benzene sulfonic acid or 2-chloro-benzene sulfonic acid, para-chloro-benzene sulfonic acid or 4-chloro-benzene sulfonic acid. Any doubt?
No, ma'am.
Okay, so that is sulfonation. Now the next reaction is alkylation. Alkylation is called Friedel-Crafts alkylation. Last year you learned, so I am going fast. Okay, so what is required? You have to take an alkyl halide. So if I take CH3Cl in presence of anhydrous aluminium chloride. So what happens? HCl will be eliminated and you will get So this is 2-methyl chlorobenzene. This is 4-methyl chlorobenzene. Okay. So that is about alkylation. Acylation is given, yes. So clear? Name is, this one is, this is 1, 2. So you can say 1-chloro, 2-methyl benzene, isn't it? So it is 1-chloro, 4-methyl benzene. This you learned last year. With the benzene you learned Friedel-Crafts alkylation. Is it okay? Now next is Friedel-Crafts acylation. So we have taken an alkyl halide. For acylation, we will take an acyl halide. I told you last year, from acid, carboxylic acid, OH is replaced by Cl. Then you will get acid chloride, H3COCl. This we will use instead of alkyl halide for acylation. So Friedel-Crafts acylation. This is chlorobenzene and acid chloride, CH3, C double bond O, Cl. So HCl will be eliminated, and that is CH3CO group will go to ortho and para position. COCH3 plus. Next one, this will go to COCH3. Isn't it? This is acylation. Last year you learned this. Isn't it? So you can name in different way. See, this is, if Cl is not there, this is an aromatic ketone called acetophenone. So in the book they have given like that only name. It is 2-chloroacetophenone.
Ma'am, is that plus chlorobenzene plus, or is it connected?
This is acid chloride, acylation, CH3COCl, this only. This
So it is
this
chlorobenzene
side.
plus.
Huh?
It is chlorobenzene.
Aluminium chloride. For Friedel-Crafts, anhydrous aluminium chloride is there. What is the doubt?
Okay. No, I got it.
HCl will be eliminated. So the COCH3 group will go to ortho position and para position. Isn't it? So I told you, if chlorine is not there, this is also a ketone. So we are giving preference to the ketonic group for naming. So that is why 2-chloroacetophenone. If it is not there, this is an aromatic ketone called acetophenone. So 2-chloroacetophenone, 4-chloroacetophenone. This is 4-chloroacetophenone. Is it okay? Clear?
Ma'am, can you please repeat once?
This name.
This reaction,
Name you
ma'am,
write
the chloroacetophenone.
Huh?
This entire thing, ma'am, the chloroacetophenone.
Okay. You can't hear this. You can see. You cannot see this.
I can, ma'am.
Ma'am, what is that? Anhydrous?
Ask. What? What?
In the reaction, it is anhydrous. What have you written?
Not
That's
clear.
not clear.
Your voice is breaking. Say.
I'll
What is the
just text,
doubt?
ma'am.
Which one, Saurav? The name? Which one you want me to repeat? The reaction? Acylation? Okay. See, this is Friedel-Crafts acylation. So we need to take acid chloride, CH3COCl. In alkylation, it is alkyl chloride. In acylation, what is the reagent? Reagent is acid chloride. This is called acetyl chloride. Any acid chloride. The chloride of acetic acid is acetyl chloride. So reagent is acid chloride. This you learned last year. Acylation. So you will take acid chloride. So how do you get acid chloride? This is acid chloride. This I got from the acid. This is acid, isn't it? COH. And OH is replaced by Cl. This is acid chloride. And so you take acid chloride in presence of anhydrous aluminum chloride, and you will then, this is electrophilic substitution reaction. Electrophile is CH3CO plus. That is why that is coming to ortho position and that is coming to para position. Coming to the name, there are two functional groups, halogen and ketone. We should give priority to ketone. So that is why I said this is carbon 1, this is carbon 2. So 2-chloro, and this compound is an aromatic ketone called acetophenone. So name is 2-chloroacetophenone, 4-chloroacetophenone. Is it clear now? Is it okay, children?
Can you explain why acetophenone?
Acetophenone because it is a ketone. You see COCH3. COCH3 is a ketone, and if benzene ring is there, that is an aromatic ketone. So here two functional groups are there, isn't it? Chlorine and ketone. So we should give priority to ketone, na? So so that is the reason I gave acetophenone and chlorine the lower priority. So 2-chloro.
Aceto is the trivial name for this thing, right?
What?
Aceto is the trivial name for.
No, not like that. I will say, not like that. Not aceto. The compounds you can say, I will say. This is a ketone. You agree? C double bond O on both sides, two groups are there. This is a ketone?
Yes, ma'am.
Isn't it? And see, this, okay, you are saying the common name, acetophenone. This is the name of the like. This is phenol, isn't it? And so, like, this is aniline. And so you can say this is the common name, but IUPAC is, last year when I told you, I said some compounds, they allow to retain the name. That is how acetophenone is taken. Like some compounds you can say, toluene and all you can say. So acetophenone is a common name, but you can use it in IUPAC name also. IUPAC name of this is, you can say acetophenone. Now clear?
Yes, ma'am. Thank you, ma'am.
Okay,
Yeah,
Anand?
Yes, ma'am. Thank you, ma'am.
So now I want to, Abhishek, tell me fast, Abhishek, Pankaj, are you there? Agnel? Fast reaction, why I am checking whether you are there or keeping phone and going. Pankaj, Abhishek? Pankaj and Abhishek, are you there? Abhishek? 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 Abhishek left. Why taking this much? Your friends are messaging you, and where are you there, Abhishek? Why are you taking this much time? I heard that you people go keep the phone and leave. Abhishek, this mic, I don't know whether you are. Okay. So we learned about, see, why are you not switching on the mic when I ask you, those children, why mic is not working only for you? So PC is okay. Other children can answer, no, fast. You have to answer me. We have to interact. And I want to know that you are getting benefited or you are listening the class. Okay. So when I ask you, you switch on the mic and answer. It's not that only few children are participating. I don't know. Remaining are listening or not. And other teachers are saying they can see 4-5 children. Why they switch on the in between? I will also ask them switch on the video, and they are switching on the video, and the teachers can see. You people, I'm not asking you. You are saying too much of data consumption, but don't behave like this. Then I will be asking you. You know that some classes children are sitting with coming with the uniform. Do you know that? In 12th itself, another section. Some classes, they come with a uniform and she can see the children. Why can't I see you? You don't answer, then see how you have to interact. When I ask you something, answer. Is there any way I can see you? You can switch on the video for some time. No? When I ask you that time, can't you switch on? That also costs a lot of data. I'm asking you something. I want to know. Video. Why you can attend only 3 classes per day? There is no this thing. I don't have a webcam in my. Okay, with those who are having phone and all the teachers are saying they are seeing the children at least 4 or 5 at a time. I'm not saying full time you switch on the video. No, data will not get over. How others or data, how they are managing. You put more, na. So how other children are you ask them na, how they are managing? Pankaj, is it you have some problem of recharging? You want me to talk to your mother? Okay, so then you are not reacting, and I think I also will have to ask you to switch on the video for some time. You are not reacting at all. So you are enjoying, you are seeing me only, and then whether you are there or not, I don't know. Then I will ask others. See, other teachers are saying we can see the children. And why are you not coming? At least for some time. Okay. Now no reaction. It is one way. I only react and some children ask some doubt. That is it. I am not able to. Whether you are keeping the phone and attending or you are there is no sign of any presence. So when I ask you a question, you switch on the video. That will not, that for 1 second, it will not cause any data. For 1 second, if you switch on the video, isn't it? That I am going to do that. Anand, just switch on the video. Where are the children? Are you there, Anand, or you also left?
Ma'am, he on this video, ma'am.
Isha, switch on. Just let me see. Why are you not switching on? See, Isha, if you switch on when I ask you, that will not cause any data, na?
Yes, no, ma'am.
Then why are you do like that? I want to see that you.
I on it, ma'am.
What?
Ma'am, both have on their video, ma'am.
So when sometimes I want to see that when I ask you that time, I'm not saying full time you switch on. I don't know how the other teachers are seeing the children. They are saying 4 or 5 children they can see at a time. Okay, Isha, fine. That is it.
Video on.
Can you see me, ma'am? Video?
That is okay. You can switch off. I saw you. Nice to see you. It does what? Then other classes, how they are managing? Here only no response, nothing. I don't know where you are attending. You don't respond. You don't answer. And only some children. That is it. Others I don't have. I don't know. Okay. So if you do not, then how others are doing? Now other children are doing that. And in one class, you may be knowing that they are coming in uniform and sitting. With the uniform photograph, we have to send the photos. So, okay, snapshots we have to send. And with the uniform, she is sending. You know that? Are you aware that? They are sitting with the uniform.
Yes, ma'am. They told, commerce students told us.
Yes. So how she is getting them in the uniform? She can see them. So we see if we are not that strict on you, that doesn't mean you don't interact. Okay, interact, fast interaction. I want to see that you are listening and you are attending. I don't think so. Everybody is doing that. Am I right? Are you listening? I don't know.
Yes,
Yeah, ma'am.
We are listening.
You are there. You always interact. Yes, Priyanka always interact. Amitav interacts. Anand. Very few only I am seeing. Naomi. Chinmaya nowadays reduced. So Chinmaya, are you able to understand why you are not?
Yes, ma'am. I asked you
So
also
these
to
many
repeat.
only are interacting. Who else? Vishnu Priya sometimes. That is it. Okay. So next topic. So what we learned about electrophilic substitution reaction. Now the next topic is a give reason question that is given in the textbook. Okay. Now the question is that suppose we are learning about aryl halides. Suppose you take a chlorobenzene. On the benzene ring, chlorine is there, isn't it? So chlorine, you know that chlorine is having minus I effect. What is that? Chlorine will withdraw electrons from the benzene ring, right? Chlorine is having minus I effect. Do you agree with me?
Yes, ma'am. Yes, ma'am.
If chlorine is withdrawing electron from the benzene ring, how electrophilic substitution reaction takes place? Electrophilic means we saw that how the mechanism I will write. Say.
Reduce.
Chlorine is in chlorobenzene, chlorine is having minus I effect. At the same time, chlorine is having plus R effect. What is plus R effect? Resonance effect. Isn't it? So I will go to the board. This is chlorobenzene. Okay. Now the electrophile. Electrophile is positively charged. If the electrophile, suppose the electrophile comes and attacks here, how the attack is taking place? This bond has to be broken and shift. When it shifts means this will happen like this. That bond here, chlorine is there. This bond is shifting, and then negative charge will come here, positive will come here. You agree? Because this bond is shifted. Electrons are given to this carbon and this carbon lost electrons. So this is the carbocation formed. So here what? This carbon is having one hydrogen and E will come here. This happens. Okay. And suppose we are taking the inductive effect. Inductive effect means chlorine will withdraw electrons. So this carbocation is destabilized because it is already positive charge. Inductive means from benzene ring, chlorine will take electron. So The inductive effect is a destabilizing act. Why? Because of inductive effect, the halogen will destabilize the carbocation. That is inductive effect. Now I will go to, this is plus minus I effect, minus I. Now I will go to plus R effect. Okay. So what happens here? Again I am writing here, the electrophile is getting attached. This will be positive, chlorine is there. Now this effect, chlorine is having 3 lone pairs. Immediately chlorine will seeing that it will give electrons. And so when it gives electron, what happens? This is E, this is H. Double bond Cl plus. So due to plus R effect, it will stabilize the carbocation. So resonance effect is a stabilizing act. Minus I effect is a destabilizing act. And both will take place. Okay, and which is stronger? Inductive effect. Inductive effect is stronger. That is the reason electrophilic substitution reactions in our aryl halides are slow, because of the minus I effect of chlorine. Okay, and so this question is given there. I will go to the textbook and read. You have to say that there are 2 effects which are opposing. So one is minus I effect, which is a destabilizing act, and it destabilizes the carbocation. And the opposite one is resonance effect, that stabilizes the carbocation. So out of this, minus I effect is stronger, but at the same time, you know that the reaction taking place at ortho and para position, the reactions taking place at ortho and para position, because resonance effect is reducing the minus I effect, deactivation, reducing the deactivation caused by minus I effect. So the last sentence you can say, the reactivity is controlled by minus I effect and orientation is controlled by resonance effect.
Ma'am, which is the destabilizing effect? It's minus I or plus I?
Minus I. Minus, because it will withdraw. If the group is withdrawing, it is minus I. Suppose the group is CH3 means plus I. The group which is giving having plus I effect. Group withdrawing is having minus I effect. So
Okay,
the question is given. This is the question. Although chlorine is an electron withdrawing group, yet it is para-directing, ortho and para-directing in electrophilic aromatic substitution reaction. Why? That is the question. Or they can say that even though halogen is having a minus I effect, electron withdrawing group, how is it possible to carry out electrophilic substitution reaction? Have you understood the question? Minus I effect means it withdraw electrons from the benzene ring. So electrophilic substitution reaction will take place only if the benzene ring is electron rich. Electrophile is coming now. So how it is happening? So you have to say that answer is given there in the book. You have to say that chlorine is having minus I effect and this is a destabilizing act because, what is the doubt? Oh, where it went? No, you are not audible. Resonance effect. See, Saurabh, 2 effects are there. Resonance effect is not minus I effect. Resonance effect will not cancel minus I effect, but it will reduce the destabilizing act of minus I effect. Is it clear? It will reduce the destabilizing act of minus I effect. Is it okay, Saurabh? So there are 2 effects. One is minus I effect, another one is plus R effect. Both are opposite. Minus I effect will destabilize the carbocation. Plus R effect will stabilize the carbocation. You will say both. Then you will say that minus I effect is stronger. Okay, that means the deactivating effect is net deactivation is more. But at the same time, resonance effect, which is opposite to minus I effect, that reduces the deactivation. That is why deactivation, that reduces the deactivation at ortho and para position. That is why this reaction is taking place. So the final point is that the reactivity is controlled by minus I effect and orientation is controlled by plus R effect. Any doubt on this?
No, ma'am.
No. What Priyanka? What is the doubt?
I understood, ma'am. Understood, ma'am.
Not clear.
I understood, ma'am.
You type. I'm not able to hear you.
Ma'am, she's telling she
She's telling-
understood.
Repeat.
Yeah.
Okay, once more. I will repeat. See, the question is chlorine is electron withdrawing group. Then how is it possible to carry out electrophilic substitution reaction? That is one way of asking question. Or in the book, even though chlorine is electron withdrawing group, yet it is orthopara directing. These two effects are opposite and how the reaction is taking place. That is it. Okay, so you have to say that chlorine is having minus I effect that will destabilize the carbocation that I showed you on the board, how it is destabilizing. So minus I effect is a destabilizing act. You can say that much. Minus I effect is a destabilizing act and plus R effect is a stabilizing act because it stabilizes the carbocation. Now both effects are opposite to each other. You can say in simple sentence also, both effects are opposite and out of this minus I effect is stronger. But this plus R effect, the resonance effect reduces the deactivation caused by minus I effect at ortho and para position. So the reaction takes place at ortho and para position. So at the end you will say the reactivity is controlled by minus I effect and orientation is controlled by plus R effect. Is it clear now?
Yes, ma'am.
Is it okay, Naomi?
Yes, ma'am.
Okay?
Yes, ma'am.
Yes, ma'am, it's okay.
Why are you taking so much time to answer? Now two more reactions are there. So you remember Wirtz reaction? That happens with the alkyl halide, isn't it? Now the next one is Wirtz-Fittig reaction. So you will take an alkyl halide, 2 sodium and aryl halide. So if Wirtz alone, where Wirtz reaction means alkyl halide alone. Wirtz-Fittig means you will take an aryl halide. So what happens? This is NaCl is eliminated and what is the compound? You will get a toluene. Aromatic hydrocarbon you will get. This is Wirtz-Fittig reaction. Okay, and here ether is there, everything is there. So how do you remember Wirtz reaction? It is 2 alkyl halides. Wirtz-Fittig, 1 alkyl halide and 1 phenyl halide. Is it okay? This is a name reaction, Wirtz-Fittig reaction.
Yes, ma'am.
Okay, next is Fittig reaction. Is it what? Now next is Fittig. Phytic means 2 aryl halides. 2Na C6H5Cl in presence of ether, NaCl eliminated, you will get biphenyl. So if you take 2 aromatic aryl halides, you will get this compound, biphenyl. That is phytic reaction. Okay, the same you can put like this also. Instead of like that, you can put 2Na. You can, instead of saying C6H5, you can draw benzene ring, NaCl. So this is biphenyl. Biphenyl. Is it clear?
Yes, ma'am.
Yes, ma'am.
See, now if you do not react, I will not ask you whether you understood
Yes,
or
ma'am.
not. I will just continue. You want like that? Okay, you have to, I don't know, no, you have to answer fast. Only 1 hour period, time is there. So with that, we finish this chapter and now exercise. And
Prashant wants one more. Once more.
once more what?
That
Which one, Anand?
Prashant wants one. He wants to
Anand,
explain.
which one you want
Ma'am, can you
to
show the
repeat?
board once, ma'am?
Which one, Isha?
Ma'am, can you show the board?
board one?
Type and tell, I cannot hear you.
No, can you show the board, ma'am? Board.
Okay. Anand was asking something.
Ma'am,
Ma'am, Prashant wanted you to repeat it.
Okay. So, see, one of you, see, if I am standing near the board and if they type, I cannot see. So, one of you say it aloud. So, phytic reaction, see, what's the reaction? You will take 2 alkyl halides. And phytic means you will take 1 alkyl halide and 1, what's phytic means you will take 1 alkyl halide and 1 aryl halide. This is phytic. In phytic, you will take both aryl halides. So C6H5Cl, C6H5Cl 2 times and 2Na in presence of ether. So you will get a biphenyl. The same way. Okay. So what I wrote down, instead of C6H5, you can draw the benzene ring. This is also, both are the same, isn't it? So that is what's phytic reaction. Okay, so words is there. Now last year you learned. Now words I didn't write now. I wrote words phytic and phytic. Which one you want, Varsha?
Ma'am, I think she's speaking about words fitting
What?
reaction itself.
Words fitting, it is there in the textbook. Now this is, you see, words fitting. Varsha, take the textbook. I will explain. In the textbook, I will explain. Words fitting. You see that aryl halide and alkyl halide. Isn't it, Varsha? Aryl halide and alkyl halide, both you have to take. Then it is words fitting. In phytic, only aryl halide. Okay? Now see.
Yes,
Now see the exercise and all. Normally for 12th, I discuss all the questions. And so this chapter, you have to write the answers in the classwork. Okay? And so how do you want? You will do yourself or you want me to explain the difficult questions at least? Because most of the questions I need to explain.
Ma'am, we'll try it once and then if we have doubts, we'll ask.
Yes,
So,
ma'am, we'll do that. We'll
Yes,
do
ma'am.
the questions
That's
once and we
better.
will get back to you with the doubts.
exercise, conversion and all you will be able to do?
we'll try, ma'am. If we can't get it,
We'll
we'll
try
ask.
once.
So conversion and all, there is a method to approach. Anyway, you will try. When will you try? And trying means not
By
from
Monday, shall
literature.
we get the doubts, ma'am, on this full chapter exercise?
See children, Trying means I know that from refresher or from the net, or if you are copying from somewhere, no point. How you are doing the homework? How many of you are doing yourself, not copying? Be honest.
Myself, ma'am.
Then anybody else doing yourself without copying?
We are doing
Then it
ourselves.
is okay. Then it is okay. Okay. So, when will you complete the
Ma'am,
exercise?
by Monday.
Ma'am, Monday we'll get the doubts and
Doubts, ma'am.
Okay. So tomorrow is a polymer. Test is there. Okay. And conversions, some reactions I have to tell you, that I will tell for conversions. Or what, see, some reactions you have to learn, because some reactions you have not learned here. In some conversion it is coming. So see, take the exercise 10.11. Exercise 10.11.
Yes, ma'am.
So ethanol to but-1,9. These questions I don't think you will be able to. Ethanol. So when conversions are coming, you will write the conversion but-1,9. CH3, CH2, C. Can you convert? No, you cannot. So some questions you require my help. Actually, I do in the class all the, but now this is online. I don't know how effective. 12th standard, all the questions I discuss in the class, because it is chemistry. It is textual. If the textbook exercise in text, if you know, you can score very good mark. So it is very important. So here ethanol to but-1,9, here you have to learn one reaction which you learned last year. You have to remember one reaction which you learned last year. That is conversion of ethyne to, see, you must have remembering sodamide. If you treat one hydrogen is replaced by sodium, so you will get sodium acetylide. That reaction you have to use here. And so this is one reaction, ethyne with sodamide in presence of liquid ammonia. Now itself you learn 196 Kelvin. You will get this compound. H is replaced by sodium. This compound you will get. And then we will use this compound to get. So this but-1,9. And so this is one reaction. So you know that it is sodium acetylide. Now from ethanol. Ethanol is this, isn't it? Or you can write it like this. CH3, CH.
Ma'am,
Huh.
the first step of the this thing, ma'am.
This is, I got this compound, sodium acetylide from acetylene or ethyne. Sodium acetylide. Sodium acetylide from ethyne. Okay?
Okay, ma'am.
And so, so this compound, now all of you write this. I think I need to discuss some questions. I will discuss some questions. Remaining I will give us homework. That will only work. Have you written this? So I got sodium acetylide. Write this much.
Written, ma'am.
Okay. So now we have to convert ethanol to. So whenever conversion comes, you will write the starting compound and the end compound. So ethanol I am going to convert it to thionyl chloride or PCl5. I will convert it to CH3CH2Cl, ethyl chloride or chloroethane. Now this chloroethane and this sodium acetylide, NaCl will be eliminated and you got but-1,9. Clear? but-1,9. Okay? Write it down. This is the first conversion. I think I will do some conversions because it is very, very important. And some questions I will do. Okay. So this way we have to, I will give you the hint and then we will do the conversions in the class. Remaining I will give some conversions I will do and you will get a grip of it. Then we will do the other conversions I will give as homework. Okay. This is okay?
Okay, ma'am.
Is this okay?
Yes, ma'am. Yes,
Okay.
ma'am.
So
Yes,
5
ma'am.
minutes are there. See, question you take right structures, all that you have done. See, 10.5. It is a board question. 10.5. A hydrocarbon C5H10 does not react with chlorine in the dark, but gives a single monochloro compound in bright sunlight. Identify the hydrocarbon. Who will identify fast? See, it will not react with the compound, does not react with the chlorine in dark, but gives a single monochloro compound in bright sunlight. So if the compound is not reacting with the chlorine in dark, it is not an aliphatic alkyl halide. So it is a ring compound. So the compound is cyclopentane. No. Cyclopentane. C5H10, the compound is cyclopentane. Cyclopentane. Right, that this is a board question. There, you just have to identify the compound. Compound is cyclopentane. Okay.
Ma'am, how did we identify this?
That is why it is required. My discussion with the question is required. Okay. You are in 12th class, na? So the why I identified, they said from one sentence, the compound does not react with chlorine in dark. So if it is an aliphatic compound, then it will react with chlorine in dark. Okay.
Okay, ma'am.
So now, next question, you tell me, you said na, you will do faster. You tell me 10.7. 10.7. 10.7. Write equation for the preparation of 1 iodobutane from 1 butanol. Tell me fast, how do you get from iodobutanol from butanol? Iodobutane from butanol. So I told you, whenever such questions come, you will write butanol, CH3, CH2OH, iodobutane. No, butanol, 4 carbon are there, no? CH3, CH2, CH2, CH2OH. Iodobutane, CH3, CH2, CH2, CH2I. Tell me first, what is the conversion? The first method of preparation, you can directly convert in one step. What is
HI.
phosphorus and iodine?
Ma'am, HI, we add HI on it.
No. HI is not there. Isn't it? See, we learned many, you have to learn the chapter properly, children. There we learned that HBr you cannot prepare and keep. You cannot put HBr directly. We use NaBr and sulfuric acid. Similarly, HI you cannot put directly. You will use Ki and instead of sulfuric acid, phosphoric acid. If you write that, that is okay. Good. Okay. So now what you will do here, I will close the recording. Your timing is almost done. So tomorrow, children, tomorrow